In the previous two lectures, we essentially looked at sets, the basic notation of sets, cardinality, equality, and in the second lecture, we glanced at what subsets are. So let's take this lecture to delve into some problems regarding the first two lectures. Let's say D is a set of 4 corner points of a square on a 2D coordinate plane with the points P. So the points are 0, 0, 2, 0, 0, 2, and 2, 2. This is essentially a square of length 2. So in this case, all these corner points are an element of the set D. Let's say the midpoint of this square. Is this an element of set D? No, this isn't an element of set D, as only the corner points are the elements of set D. So we can take this notation. Well, what's the cardinality of D? Obviously, you have 4 corner points, so you have 4 elements. Let's take another example. Let's say the set M. This time, it's set of 2 by 2 matrices. What's the cardinality of M? Obviously, there are 3 elements, so you have 3 as the order on the cardinality of M. Now, over here is 1, 1, 0, 1. Is this an element of the set M? No, it isn't, because it isn't found in set M. Only these 3 elements are the elements of set N. So 1, 1, 1 isn't an element of the set N. You remember we talked about empty sets? Let's play around with some problems around empty sets. So obviously, if a set A doesn't have any element, its cardinality is 0. This is usually known as an empty set. We also have a notation for the empty set, which is phi. So if we denote A as phi, then means A doesn't have any element and its cardinality is 0. Whenever you see this particular symbol related to sets, it always means an empty set. Also in set theory, empty set is the only set whose cardinality is 0. One thing that you guys should be extremely careful about is mixing up the empty set with the curly braces. This and this is not equal. This is an empty set. Cardinality of this is 0. This isn't an empty set. This is a set which has one element, and that element is an empty set. So this has a cardinality of 1. So this particular set contains nothing, whereas this particular set contains namely the empty set, as it's only one element. This is one of the first few points the students should keep in mind while dealing with sets for the first time. Let's move on to some more problems. Let's expand on this very particular sets having variations of empty sets as its elements. Let's take a set K which has these elements. Well, what's the cardinality of K? It's 3 because it has 3 elements. Always remember, a set can have a set as its own element. What you can draw an analogy with is, think of K as a box containing 3 things. An empty box. This one is an empty box. This, let's say, is the boss box. So the boss box contains an empty box. It contains a box containing empty box. And the third element is a box containing a box containing an empty box. Let's play around this particular concept a bit more. In the first lecture, we saw that n is the set of natural numbers. So essentially, you can write n as 1, 2, 3, goes on, and z a set of integers. So we saw z as -1. So essentially, z is -4, -3, -2, -1, 0, 1, 2, 3, 4, ... Let's assume there is a set G which consists of 2 elements, the set of natural numbers and the set of integers. So what's the cardinality of G? It's 2. And what are the elements? The elements are the set of natural numbers n and the set of integers z. Keep in mind that the cardinality of G is 2, whereas the cardinality of n and z are infinite. You remember we briefly touched on this notion of finite and infinite sets. We also talked about the set builder notation. Let's take some examples. Set of all n such that n is a prime number, starts from 2, 3, 5, 7, 11, and it goes on and on and on. Let's take another example, n square. Set of all n square says that n is an element of the integers set. So what does the integer set contains? So this is the integer set. This particular set x, let's denote this as x for the sake of brevity. X is a set of all n squares where every n belongs to the integer set. So every element of z needs to be squared up in order to form the set x. Now keep in mind that the square of minus 4 is exactly equal to the square of 4. So both of these would result in the same number, 16. And in a set, we can only have that once. Hence, the solution would be the square of all integers, which is 0, 1, 4, 9, 16, 25, and so on. Let's take another example. Let's take set y, where the elements are integers which satisfies this particular condition, x squared minus 2 equals to 0. Let's take a look at this particular condition, x squared minus 2 equals to 0, which means we have square equals to 2, and the solution for this is plus minus root 2. Now as we know, plus root 2 or minus root 2, both of these aren't the element of the integer set. So in this case, y doesn't have any integer as the solution for the equation x squared minus 2 equals to 0. So this is an empty set. Let's take another example. Let's say set G is a set of all x which belongs to integer which satisfies the condition where the absolute value of x is less than 5. Let's talk about this notation for absolute value briefly before solving the problem. The notation double bars and within absolute value is, while denoting any integer, you have two things, the sign and the number. While denoting any number, you have two things, the sign, which can be positive or negative, and the magnitude of the number or the value of the number. Let's say that is a. Now absolute value just deals with this magnitude, and the notation for denoting the absolute value or just the magnitude of a number is, in this case, a is a number and the absolute value of a is denoted as e within this double bars, and it's just the value without the sign of that particular number. Now let's get back to the problem. Over here the problem states that G is a set of all x which are integers and absolute value of x is less than 5. Now let's think about this condition, absolute value of x. Now set x belongs to integers. So once again, let's think from the first principles. The set of integers essentially are something like this. Now let's pick any number from any positive number. Let's say 3. What's the absolute value of 3? It's 3. Well, what's the absolute value of minus 3? It's also 3. So we need to find out all such x's which are integers whose absolute value is less than equal to 5. So we can rewrite this particular condition as something like this, and obviously for any absolute value the minimum number will be 0 because an absolute value doesn't have any sign associated with it. So by default, the minimum value should be 0 and positive. So these are the only two things that the absolute value can have as its solution. So we can also rewrite this as, now if we take a look, so we need to find all such x that belongs to the integer set such that the absolute value of all such x's would be greater than equal to 0 and less than equals to 4. So if we take a look, minus 4 and 4, both of them will have an absolute value of 4. Similarly, minus 3 and 3, minus 2 and 2, minus 1 and 1, and 0 as it is, it doesn't have any negative counterpart. It's just 0. Keep in mind, we cannot have minus 5 and 5 as a solution of this particular. So we need to find out all such excess which belongs to integers which satisfy this particular condition. The absolute value of that particular x should be less than equal to 4 and greater than equal to 0. So let's take a look at the integer set to figure out which numbers are these. Take a look, then -4 and 4 both will have the absolute value 4, -3 and 3 will both have the absolute value 3, -2 and 2 will both have the absolute value 2, -1 and 1 will have the absolute value 1, and 0 will stay as it is. So our solution set, or the set G over here, will be something like this. Please keep in mind, having -5 or 5 won't count, because that would mean the absolute value of x would be 5, and that can't be a solution to this particular equation. Let's take another example involving set builder notation and the absolute value. Let's say y is a set of all x which are integers such that the absolute value of 3x is less than 7. So let's break this set notation down. The first condition is that the elements of set y are integers. The next condition is for all such x which are elements of y and are elements of integers, 3x, what absolute value of 3x is less than 7. Now let's try to come up with the solution. We know the set of integers, it starts from negative. So z is a set of integers which we know is this. And the second solution, and we can then rewrite this next part as something like this. Then if we take a look closely at the set of integers, we need to find all such x. So if x is 0, 3x is 0, the absolute value will also be 0. If x is 1, this is 3, this is 3. If it's 2, it's 6, this is also 6. If it's -1, this is -3, this is 3. It's 2, this is -6 and 6. So this is the solution. These 5 elements are the solution of this particular set y. We cannot have anything more than that. We cannot have -3 or 3, then it would result 3x, the absolute value of 3x being 9, which obviously doesn't satisfy the condition. So the solution for this is this. Alright, let's take a different problem. Let's deal with now a set whose elements are sets themselves. Let's say A is a set whose elements are 1, 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10. Let's also denote one the set which is a set of x which belongs to A such that the cardinality of x. Let's denote a set B which is a set of all x that belongs to set A such that the cardinality of x is less than 3. So you can see set A is a set of sets. The cardinality of the first element is 2, the cardinality of the second element is 3, the third 1, and the fourth is 4. So we need to find out the elements or the sets whose cardinality is less than 3. So essentially we can rewrite this as something like this, and only the first element and the third element satisfies the condition. So set B is this. That's it for today's video. We will take a look at some more exercises in set theory in our next video. Thank you so much for tuning in, folks. If you enjoyed today's video, make sure you hit the like button. It really helps the channel out. Don't forget to subscribe and ring that notification bell so you never miss out on our upcoming content. Have a question or want to discuss further? Drop a comment below. I'm always eager to delve into these problems with you. As always, thank you for your support, and we will catch you in the next video. Stay awesome.